Okay, Foundations Pre-Calc 10, let's get after it. We have a short video on slope-intercept form, everybody's favorite. We've seen this form in grade 9 already, and this is, in my opinion, the best one. It just gives us the most information. It's so lovely, right? Y equals mx plus b. What do we have? We have the slope. It's staring us in the face. What do we have? We have the y-intercept. It's staring us in the face. With those two pieces of information, we can plot any graph that's of a linear equation, and it's just great. So we have to convert into that. It's really helpful. This is not super easy to graph, right? Well, let's convert into slope-intercept form and see what information we get. So I'm going to subtract 3x from both sides because I need my y alone, right? That's the whole thing. And now I have 5y equals negative 3x minus 2. I just reversed the order of these two numbers because you can put them in any order, and we want to have our x term first. And then I have to divide everything by 5. Now in this case, are we going to have a beautiful, perfect whole number or integer y-intercept? No. We're going to have y equals negative 3 over 5x minus 2 over 5. It's still plottable. 2 over 5 is just a little bit less than a half, so you can find a spot on there, but we just work with that. But at least we know our slope and we know our y-intercept, and they're not hidden from us. They're staring right at us. So let's do another one. Minus 3x from both sides. I have negative 7y equals negative 3x plus 12. Subtract negative 7 from both sides. And would you look at that? I have y equals 3 over 7, because my negatives cancel, minus 12 over 7. And again, sure, this isn't ideal as a y-intercept, but no big deal. Here's my slope. At least I know that information. This is an example that I'll touch on in a future video, where if you look at the standard form, right, when y equals 0, this is 0. So we would end up with 3x equals 12, right? This is when y equals 0. And that's easy to solve. You end up with x equals 4. So that means we have a x-intercept at 4, 0. So you can get a perfect intersection point using standard form. And then you can use the slope from slope-intercept form to map the rest of your graph, right? And it's just a rough mapping. But so you can use the two different forms to pull perfect pieces of information to help you graph a much cleaner line. Because negative 12 over 7 is 1 and a bit. So obviously this graph's off. It's not to scale by any means, but the y-intercept isn't at a perfect integer junction, but the x-intercept is. So using information that we have can be really, really helpful. So here's one more. So again, same process. Get my y by itself. Subtract 3x from both sides. Negative 9y equals negative 3x plus 12. And then divide everything by negative 9 by negative 9 by negative 9. And in this case, we get y equals 3 over 9x minus 12 over 9. And this can all be simplified to y equals 1 over 3x minus 4 over 3. So there it is again. The idea behind this entire unit is algebra. Can we use equation manipulation to get an equation of a linear function into any form that we want? It can be incredibly helpful given a particular situation, and it's all about versatility. Keep working hard, you're doing great.